Hi, Volker. Welcome back.
Hi, hello, Adam. Nice to be here again. It was fun last time, so I hope it will be fun this time again.
Hopefully even better.
Yes.
What I thought a lot about is the predator plants.
Which plants? Predator?
Yes. This is, the plants who are eating flesh, animals.
Predator plants. Yeah. Yeah.
Which kinds of such plants are available, or out there? So one, or maybe what I'm interested most, which plants are moving, right? So there are some moving plants, and I only know one. And are they different?
Yeah. So is this? I think the Latin name is Dionea muscipula or something like this. Is the one? Yes, the catcher plant, which has
okay.
and that is really moving. There is the other one, which is Drosera, which has this glue, like a lot of small drops of glue on it that catches flies because they
but this is boring.
They also move, but they don't move so fast. So once a fly is on the glue, the leaf is still closing around the fly or the insect, but it usually takes like 10 to 15 minutes, maybe even an hour. So that takes a lot. And then there is this Nepenthes, which is basically like a glass, and with some digestive water inside. So the insects just fall inside and get digested. So that's not moving.
Okay. So there are three categories of plants.
There's like this Nepenthes. They live on the trees, and this like glasses or bulbs. They are hanging down. They look very nice. And there is another sort which is called Sarracenia. They live on the ground, and they are like this champagne glasses, like very long, and they have some hairs which in the inside which go in the inside direction. So once the insect is inside it can only go down. And
like a diode, right?
Yeah, exactly. And then at the bottom there is also some digestive liquid there, and they get digested. But
are the plants still living outside in Germany, or is it like
there is like the ones with the glue? They are living. There is Drosera rotundifolia. That's like the European one. There is not so many in Europe, but that lives in Europe. And there is actually another one which is moving. And it's actually quite spectacular, but it's very small and it lives in the water. It's called Utricularia. So this is like the other one, the catcher plant, which catches the flies by closing the leaves. But this one works with vacuum. So it's like a camera which has a vacuum, and when a small insect in the water swims in front of it, it just opens and it gets in the water with the insect. So, but it like this catch itself, the plant itself is just like 1 millimeter or 1-2 millimeters big. So it's not so spectacular if you don't look at it.
No, but it's so interesting that's moving. Yeah. Okay. And we have to clarify, you are the expert of such things because you are the chair or
I'm
the chief of German predator plants, right? So this is like
I'm just one of the very early member of the club, but I'm not a chief.
And what's the German name of the club?
Gesellschaft für Fleischfressende Pflanzen, GFP.
GFP. This is like the what is Gesellschaft? Association of flesh eating plants.
Yes, exactly.
It's even there's a garbage collection, everything already included, right?
That's true. Yes, that's true.
Okay, last time we talk about your journey between Sun Microsystems and then SAP. And then we finished because it became interesting again, and we wanted to stop at one point of time. And and you said SAP was interested to have an own JVM, Java Virtual Machine.
Exactly.
So, and you know why?
Yes, because that was the time of, let's say, Java 1.4, 1.5, and SAP at that time they still most of the SAP stack is built on ABAP, which is their own programming language, which is a story by itself. I'm not very familiar with that. I try to stay far away from it as much as possible. But at that time, like Java became very popular in the enterprise, and we had this Java EE coming up, Java EE standard, Java application servers. So SAP decided to also build a stack based on Java EE. We had the so-called double stack, like it was very complicated. And I think
NetWeaver, right?
Sorry? NetWeaver, yeah, exactly. NetWeaver. That was NetWeaver. It was basically a Java EE server. But I think it didn't work out, like in the long term, it didn't work out very well because I think they tried to basically transfer all the goodness and patterns and everything they had in their ABAP server to Java. And that just didn't work. I mean, Java has some other trade-offs and other strengths and weaknesses. So trying to rebuild everything the way it worked in ABAP in Java just wasn't the greatest idea. But anyway, they had this NetWeaver Java EE stack then. And at that time, most or basically all SAP customers ran on this big Unix servers. And there were many of them at that time. There was HPUX, AAX, S390, Solaris, and they ran all on different architectures. HPUX still ran on PA-RISC and Itanium, and then AAX on PowerPC, Solaris on Spark. And initially, this NetWeaver required the vendor JVM. So every vendor like HP, IBM, Sun, they all had their own JVM. But although Java is write once anywhere, write once around anywhere, right? There still were some differences. For example, they had different GCs, different JIT compilers, different performance, different command line options. So it became very hard for SAP to maintain this NetWeaver stack on all these different JVMs, and that was the reason why they decided, well, let's do one JVM which runs on all systems. It might still have like different performance. It might still have different performance on different platforms, but at least it will have the same the same command line options, the same support. Support was also a very big issue because SAP products are supported like a minimum for 10, 15 years, right? Maybe even longer. And Java, the JVM just didn't catch up with this long support time frame.
Maybe this was the reason, right? Because they could just pick the JVM from Sun back then. So it was, I think it also ran, it was not available on the Unix systems. This is what you're saying, right?
No, I mean, the Sun VM was available on Spark, Linux and Windows, but not on AX, HPUX, for example.
Okay. So you had to port it, the Sun to the Linux derivatives,
yes,
right?
So we evaluated different options, and actually, in the end, we remained with two options. One was to license the source code of Hotspot or license the source code of IBM J9. But IBM didn't want to give us a source code license. They only wanted to sell us basically the product. So we ended up licensing Hotspot source code from Sun Microsystems. And we got a full source license, and then we started to port it to all other platforms. And that was actually when I joined the team, and my first task was to port Hotspot to PA-RISC on HPUX.
This is sounds to me like Mission Impossible.
No, it was actually not that bad. Like you start with the interpreter, and
but you had to know where to look at, right? And you need to know the build system. This is quite a task, right? I mean, if you get a source code and you don't know the source code, getting custom.
Sure. I mean, you don't do it in a week. We worked on this for years. So we started with HP PA-RISC, then we did HP.
Was it well documented, the source code, or how you started? You get a bunch of C code. So what you did then? So you got some tests, or what you got? Just a source, or was it? How?
Yeah, we got the source, and I think they had a porting guide at that time, which, as always, these documents are outdated, but it was okay for the beginning. I mean, documented at least the basic parts like the interpreter. Maybe you remember Hotspot had a C++ interpreter and a template interpreter at that time. So the C++ interpreter has long been removed. Actually, it still works for the 0 port, but not for the other platforms. So the C++ interpreter was not that hard to port. It's basically all written in C++. You can think of it as a big switch loop. For every bytecode, you switch to another switch block, and the only thing you have to do in assembler is basically the stack handling, because like you have to basically integrate the Java stack with the system stack. But that's what's done by libraries like libffmi, for example. But we didn't use that. I think that didn't exist at that time. But that's basically what you had to implement. That's like a few thousand lines of assembler to get the C++ interpreter basically running. And you needed a C++ compiler. That was also not easy at that time. Like
why assembler? Why you had to do it in assembler?
Because you cannot there is no C functionality to manipulate the stack and the return addresses on the stack. I mean there is alloc A which increases your stack frame, but you really need to basically you need more functionality to handle as I said, to integrate your C++ stack with the Java stack, which also has locals and temporaries and return addresses and all this kind of stuff. So and once you call into Java, then you build all these Java frames on top of one native frame, and then again you call back from Java to C++. Then again you switch to a basically compiler setup frame. So this it's mostly this frame handling and the code.
It was completely. Of course, you had to use assembler because we are talking about the hotspot, right? And what hotspot does, it generates machine code, right? At the end of the code. Yeah, this is why you are very low level. So porting means it's not like I thought why if you ported the C code to a different operating system, why you had to use assembly, but you had to understand assembly in order to generate the proper machine code for the target platform, right? This is what we talk about. Okay, now I understand.
Yes, I mean, but as I say, for the C++ interpreter, you don't generate a lot of assembly code because the interpreter itself is written in C++. The only part of the interpreter is, as I said, is like call sequences and stack handling, which has to be done in assembler. Everything else, like the implementation of every bytecode was more or less written in C++. That's why I say it was not so hard to port the C++ interpreter.
But nonetheless, we are on the lowest level usually, right? This is why you had to go deeper than usual, right? So it was not deporting means the C++ was usable right away. But in order to make it more efficient on the platform, you had to do some low-level stuff. This is the adaptation, right, to the platform. And because Solaris was that different to the PR, what was it? PR9, you said?
PA-RISC.
PA-RISC. I never heard about this. What is PA-RISC?
I think it's performance architecture.
Or power?
No, it's power is different. Power, it's not power PC.
PR, you have to look it up. Which machines were there? I never heard about it.
HP 9000 or so.
HP, okay. Yeah. Okay, this is the HP Unix. HP Unix? Yeah. And PR9 is the CPU architecture from...
Sorry?
The PR9 is the...
PA.
PA.
PA-RISC. Yeah, like performance architecture. I think it's called performance architecture.
This is from HP is the CPU, right?
Yes.
Okay.
They don't exist anymore, but
no, but never heard about that. PA.
Yeah.
Interesting. Okay.
They were replaced by Itanium. Then I just looked it up. So it's parallel precision architecture reduced instruction set computer. So that was
interesting.
That's what PA meant. Yes.
And this was your first task to port the hotspots to PA.
Yes, exactly. You usually started with the C++ interpreter because it was the easiest and required the fewest lines of assembler code. Even that is not trivial because at that time C++ compilers weren't really compatible with each other. So PA-RISC had its own C++ compiler. There was no GCC, or there was a GCC, but we couldn't use that because we wanted. I mean, some people use JNI, for example, to work with the JVM, and then all the native libraries on HPUX, they were compiled with the platform compiler, and they had different calling conventions. So it was not possible to create, for example, a shared library with GCC and then use it from a program written with ACC. I think ACC was the name of the HP C++ compiler. So first was make the C++ code compatible with the HP compiler, then port the C++ interpreter. Then you start you start interpreting bytecodes, right? So you get the first bytecode. Yeah, I can interpret one bytecode, second, third, and you can do a jump or a call bytecode.
So coffee baby. So you saw that you saw this a lot of times, right?
Exactly. And like executing hello world. I mean, once you execute hello world, you can execute a hello world program. You're basically done, because executing hello world executes about 2 million bytecodes already. So because that basically loads up the whole class library and does a lot of stuff in the background. So once you, as I say, execute hello world, it looks pretty good.
This a good would be good as student assignment, right? You only have to do hello world. Everything else doesn't matter, right?
Exactly. And then once that worked, you jump to the template interpreter. So template interpreter is still the interpreter which is used today in Hotspot. And that, as you said before, that basically is a generated interpreter at startup, and that generates assembly for every bytecode. And every bytecode automatically dispatches to the next bytecode through a bytecode table. So that's much faster, because you don't have this switch loop where you basically have to, every time you execute the next bytecode, you basically do this binary search to find the right block in the switch code. Like the template interpreter just has one indirection, like just jump to the assembly snippet for the next bytecode. But then again, it requires you to write all these assembler snippets manually by hand. Then template interpreter was already almost I don't know, 5, 6, maybe even 10 times faster than the C++ interpreter. So considerably faster.
And you know how you got the source code from Sun? No, this was just a download link, or was it more, some official process? Was it, I don't know.
At that time, it was really just source drops. It was just zip file
interesting.
Source. Yeah.
So I know and then security guards came in, with the DVD full of source.
I think
special ops.
Yeah, I think when I started, we already had download links, you obviously have to authenticate. We also got the TCK, which is also an important part. There were not a lot of other tests available in the source code. So this JTREC test, which are now part of OpenJDK. If I remember right, I don't think we had them. We only had basically the TCK tests, and we used TCK to obviously certify our ports once.
You had to certify them as well. Yeah, of course.
Sure. Certification was a huge task, especially because in the end we had so many different platforms, and you had to do certifications on all of these platforms.
Did SAP had more platforms than IBM?
Yeah, I think at one time.
This is actually I didn't knew that actually SAP had that many ports. This is interesting. It was also it was quiet around that. So it was not.
Yes, because we didn't offer standalone JVM, like the SAP JVM, how it was called. It was only bundled with NetWeaver.
Okay. Now I get it.
So only people who basically bought NetWeaver got the SAP JVM for free, but you couldn't just license the SAP JVM. And it was actually also a licensing issue. We only were allowed to bundle SAP JVM with SAP products. So
interesting.
Yeah.
And were there any added value on top of that? So you implemented some,
Yeah, we did a lot of additional stuff in SAP JVM. at that time there were not a lot of tools available, so we built our own profiler, for example.
This is Matt.
Sorry,
Matt.
Yeah, Matt. That's also something we did. Yes, that was finally then
memory analyzer tool with
memory analyzer tool. But we had an internal profiler which is similar to what can you compare it to Java Mission Control, maybe.
Okay.
JFR, Java Mission Control. We basically at that time all the Java profilers were SafePoint based and all had the SafePoint bias. So I think we were the first ones who introduced something like that was called SafePoint, profiling SafePoints. So we put special SafePoints into the code at a lot of places in order to make profiling more accurate. Because like the Hotspot SafePoints, they are quite heavyweight, because a SafePoint in Hotspot is a point where you can deoptimize just-in-time compiled code. And you need all the information to build an interpreter frame at that point of execution and return and continue execution in the interpreter. Now, when you imagine that compiled code is highly optimized and does a lot of inlining, it is quite complex to deoptimize such a highly optimized JIT compiled method, because like when you, for example, think you have inlining level of 6 or 7 methods, and you deoptimize at that inlining level, you have to rebuild all these 6 frames as interpreter frames, as 6 invocations on the stack. Like in the compiled method, you just have one native.
Is invocation and frame the same?
In the interpreter, invocation and frame is the same.
Okay.
For a JIT invocation, like a JIT method, as I say, it can do several levels of inlining, and then for a JIT compiled.
So what is inlines is the frame. So you have one invocation and several. Now, wait a second. One frame with several invocations, because inlining reduces the invocations, right?
Yes, if you inline a method, you don't have to call it, so you don't have
exactly.
to
So usually you have one frame, one invocation, and with inlining you have one frame, and inside are multiple invocations, right? So this is how would be.
Yes, basically the invocations get folded. You don't have to call it anymore.
Inlining, exactly.
But when you deoptimize and go back to the interpreter, you have to rebuild these frames then.
And the optimizing is because we are rejecting the optimization strategy, or?
Yes, because, for example, JIT does optimistic optimizations. Like, for example, it only sees one target for a virtual call. So
this is interesting, the optimization, and why you cannot keep the origin code, and then just reject the optimization and do it again. So it is cheaper to go backwards and de-optimizing than,
No, because you just don't have, as I said, imagine, for example, you have a virtual call, and when you compile the method, there is just one target for this virtual call. There's just one class implementing, right? So you can inline that.
Yeah.
But then at runtime, you might dynamically load a second class, which also implements this method. And you might call that one. So the inline code is now incorrect. And there is a guard in the compiled code. And when you reach at this guard and it checks that the target type is now different than for what your code was optimized, you just cannot continue in the JIT compiled method. So you have to do something.
This is what I understand. But
that's the optimization.
Why I ask you the optimization is because if we optimized and then rejecting, so the optimization sounds to me like, reading what you optimized and trying to get the origin state, right? So
the optimization just means going back to the interpreter, because the interpreter.
Okay. So it's not like you try to reconstruct, the origin point. It's just, rejecting, and you're going to interpret and happens again, right?
Yes, but in order
perfect.
In order to go back to the interpreter, you have to rebuild this state which you had in the compiled method, which was optimized rebuild it to develop the
interpreter. Then is even so you have to rebuild the state, but you could also keep the state as origin one, and then reuse it. But this is too expensive, or it consumes too much memory, or why? Because it seems to me like the origin state was rejected. Then you have only the optimized state, and then if you're rejecting the optimized state, you have to know to de-optimize it to get the origin state again. You know what I mean? It's like I could keep, the origin method in memory and optimizing. Then I have both, the interpreted and the optimized version.
I mean, the method is still in the code cache. The optimization just means that you have a stack, right, with all your invocations, and like on top of the stack you have a compiled method which has inlined other methods. And at some point in time you realize that you cannot continue execution in the compiled code because it's not valid anymore.
Okay.
So you somehow have to continue now, and the only way to continue is in the interpreter. But the interpreter has a different stack layout. So you basically throw away the top frame.
Top frame so you're just going up. So you're just moving up and to the method you wanted to have, and then do it again, right?
Yes.
This makes sense. So I thought this is more.
You basically remove the JIT compiled frame, the frame for the JIT method, and rebuild several frames for the interpreter which correspond to the state which you had before, and then you basically re-execute the bytecode which calls the optimization.
You're right, because the thing about this, if you have, let's say, 6 levels of inlining, right? Yes. So maybe only the 3 are incorrect. So you could move up 3 levels and just re-optimize the 3 levels, right? Or you always had to.
No, if you de-optimize, you basically have you throw away
everything.
The top frame, which inline 6 methods, and then you rebuild the 6 frames for the interpreter.
Okay.
And then eventually you recompile the method and run compiled again. I mean that's all dynamic, but the optimization that's the hard part to do. And actually we came to this discussion because I was talking about profiling save points, right? So this is the optimization point, like every other save point, which is used for usually the optimization and save point are 2 different things, but they both need to keep in the hotspot. It's called VM state. That's basically you need to know the value of all locals. You need to know where all your locals and temporary values are stored, because also at the save point the GC can run. So for the optimization you need the VM state in order to reconstruct the interpreter frames. At the usual save point you need this information because the GC needs to find all the routes. So that's why such a save point is complex and contains a lot of data. So we introduced these profiling save points which didn't have any local data, but which were at these profiling save points we could only stop to walk the stack to get a stack trace for profiling. So that's why basically our profiler, the SAP JVM profiler, was not save point biased as all the other profilers at that point in time. So that was one of the features we did. We also had a lot of serviceability tools like JCommand nowadays, because at that time that all didn't existed. So we wrote all this stuff, and it was quite good for us to support our customers, and I think customers also liked it. But at that time there was no OpenJDK, there was no open source. So as you say, nobody knew about it, which was a little sad. And that was actually the reason why when Sun announced open sourcing their hotspot as OpenJDK, I instantly jumped on the project and tried to get involved in this project, and also suggested to SAP to get involved in the OpenJDK project, because like doing this all on your own is not that fun, because you cannot share with other people. But it was not trivial, really, because at that time open source was really evil for SAP. Like it was how many years ago? 20 years almost. So 15
JDK
years.
1.5 around, right? JDK 1.5, 1.6.
1.6, yeah. I mean, the first version of OpenJDK was like the first development version of Java 1.7. But then it was like the first task in OpenJDK was basically this retroactive port of 1.6.
Then I think it was around 2006, 2007, something like this.
Mm-hmm. Yeah, almost 20 years, 50 to 20 years, yes. The another reason to get involved in the OpenJDK project was that although we were a source code licensee of Sun, like the support was not really great. So like it was hard to get in touch with the real developers.
Mm-hmm.
Like you always had some license engineering and first level and second level support, and like we were a group of VM engineers, and basically we were at that time already quite experienced with the GC and JIT and everything, and having to walk through all these levels until you get to a real engineer was really a pain. And I remember...
I can imagine the first question, right, on the first line support is like, have you tried to compile it with Java C? Did you have, enough memory? If out of memory happens, right?
yeah, it's exactly this kind of stuff. And like we had some of these funny bugs which we opened. Like then license engineering, they basically opened JBS issues for us. Like the Java bug system was already online, but not accessible as nowadays for OpenJDK contributors. And then sometimes a lot of this just vanished, but sometimes they, even after OpenJDK already existed, they fixed a bug which we submitted like 10 years ago or so. Then we really celebrated because... But it basically showed that the velocity was very, very low.
Mm-hmm.
And that was another reason to jump on the OpenJDK itself and start working there. But as I say, open source was not popular at SAP at that time. It was even deemed evil. So it took me like, I don't know, 1-2 years to convince the people.
And you were able to build the OpenJDK source code from the beginning?
Yeah, sure. Because I mean, we already had the experience.
I remember it was a London conference. I think it was JAX London, and there was a community event where they tried, to compile the OpenJDK first time. So this was a event. So this is.
I think I signed this personal contribution agreement, Sun contribution agreement, like at the very beginning, like first months or so, which was kind of unofficial because, like as I say, it was a personal contribution agreement, not one for the company. And then it took me like almost 2 years to convince management to basically sign a contribution agreement for SAP and join as a company. But then guess what happens? Then Oracle bought Sun, right? So Oracle was the biggest enemy of SAP. So we were really almost done to sign the contribution agreement, and then Oracle bought Sun. So again, one lost year again, because nobody wanted to take the risk of, no executive wanted to take the risk to sign such an agreement with Oracle. So it took us yet another year until we finally signed the contribution agreement. And started
but from the SAP perspective back then, it was actually no risk, right? Because if you would sign that, you could actually base your development on OpenJDK, and you could move faster without any disadvantages, or not, right?
Yes, but I mean, there is all this legal stuff involved. There is this field of use restrictions. There is
The problem is okay. You had the 2 licenses then, right? The Sun could say, okay,
yes.
It was based. The work was based on the origin license. Is not compatible with the open source license, right? This could,
Yeah, and there's you also like you still cannot call OpenJDK Java, right? I mean, Java is a trademark, and that's different from OpenJDK. Like with the license we had for SAP JVM, we could call it Java because like we were a Java licensee. So it was unclear if like SAP customers had the right to get a Java, like Java TM virtual machine, or if we could just give them an OpenJDK, which is Java certified. So yeah, there were a lot of uncertainties at that time. But this actually led to this delay led to the fact that the first port which we contributed to OpenJDK was the PowerPC port. Like initially in initial discussions with Sun, we planned to contribute the Itanium port because at that time there was no Itanium port in OpenJDK. Sun had a commercial Itanium port, and Intel also had a commercial Itanium port, but there was none in OpenJDK. So we thought, well, Itanium makes most sense to contribute it because there were so many different ports. It might make sense to have one in OpenJDK, but then after all this delay, Itanium basically become really unimportant because I think Intel basically
they discontinued the entire.
They announced that they will discontinue it. So then we started with PowerPC, but that also was not so trivial because like PowerPC was basically done by IBM. So we also had this background discussions with IBM and Oracle, and we had a lot of nice meetings with Oracle and Sun about how to do this, and in the end everything agreed to do this. And like we were the first contributor of an external port then with PowerPC on Linux and also on AAX. So it was not easy to integrate this port because, for example, at that time it was still impossible for external contributors to push changes to Hotspot directly. At that time, by the way, we still used Mercurial as HG control system. HG. Exactly. Not GitHub. Again, like for us, we only got the source drops as zip files. Mercurial was really a big improvement. That we like after OpenJDK started, we also got our license sources through a secured Mercurial repository, but also in the OpenJDK we had the Mercurial repository, so you had the whole history, commit history, and all this kind of stuff, which was really nice and really helped with ports and with bug fixing and with everything. But as I said, it was not possible for a long time to directly push. You had to give your changes to a Oracle engineer, and he had to run it through the internal Oracle test systems. And only if everything passed, it was committed. And if there were problems, it was hard because they couldn't really share the tests because a lot of the tests were not public at that time. So it was really painful.
They're really painful. So I imagine even trivial Java code would be painful.
Okay. Yes. Yeah. And then they eventually made it possible to push to the class library. Because with Mercurial,
to the class library. You mean your class library, or?
Yeah, I mean at that time, maybe you remember we had this. It was a tree of a forest, a Mercurial forest of repositories. You had a base repository, and then you had a different repository for Hotspot, one for the language tools, which was the Java C compiler, one for the core libraries, which is basically all the Java class libraries together.
And you also contributed to the core libraries, or you, SAP back then?
Yeah, I mean, we contributed to everything because, like, when you do a port, for example, for AAX, you have to implement, for example, socket or file.
Sure, socket, AWT, all the stuff is everything is native, of course. Yeah. So, but it's just just the adapter logic or the port related stuff, right? So you didn't contribute new functionality to the library. It was
just the
native part.
The native part, exactly.
Okay. And how many ports you did at SAP? PA
like
or
to the OpenJDK, we only contributed like PowerPC and on AAX and
in total,
and later S390 for Linux. But like internal, as I said, we had on Itanium we had HPUX. And Windows Itanium was really the biggest pain in the ass because like the CPU architecture was really crappy, and then Windows running on that. That was really catastrophe. And Linux, actually, yes. So on Itanium, we had like 3 operating systems: Windows, Linux, and
What I remember, the Itanium had thermal problems, right? They run hot. This was the problem. They were very power intensive, and they generated lots of heat. This is what I remember. No, you remember that?
Yeah, that might be, but they were all in the data centers. Like that didn't really.
Okay. No, sure.
But Itanium had like, I mean, it was a completely different architecture. It had, for
64-bit or something, right? This was like,
yeah, it had 64-bit, but it had, for example, 2 stacks: a register stack and and your usual function stack. So like dealing with these 2 stacks was already very painful.
Okay.
And then you had to do all the scheduling yourself, because you had these large instructions. I don't know, it was like 128 bits, I think, and you had to manually place like 4 instructions into this 128 bits. Basically, do instruction scheduling by hand, and if you didn't do that in a good way, you got very poor performance.
Okay.
So, I mean, nowadays,
so you were happy that it died, right?
Yeah, we were very happy when it died.
This was celebration. Okay, so there was Itanium, there was PA, there was okay.
Yeah, PA-RISC. We had just HPUX on PA-RISC. Then we had PowerPC, Little Endian, Big Endian with Linux and AIX. S390 Linux. We had AS400 on S390, and I think that's basically it. Yes, but it was like 12 or 15 platforms.
So it's actually a huge project.
Yeah, sure. We were.
How many developers? 50?
No, not that many actually. Maybe, I think we never were much more than 20 developers. Like,
okay.
And on the VM itself, probably not more than 10.
Okay.
Like other people's mostly working on all our tooling, as I said, profiling,
yeah,
and management, and all this kind of support tools. And
so you were an OpenJDK contributor from day one, or
yes, basically yes.
So you were one of the very first one, or how many you were before?
I don't know who is the first one. I don't know who counted.
Well, we can assume for the podcast you were the first. So now everyone. Now it's fact.
I don't want to claim that. Maybe.
No, but I can claim now. You were the first. This is better for the podcast, and now I know it. Volker was the first.
Red Hat was very active. I mean, Red Hat basically negotiated and helped Sun to do this open sourcing, because like the background why Sun open sourced OpenJDK was manifold, but one of the reasons was that at that time Linux became very popular and people started to using Linux instead of the proprietary Unix systems, which I told you, like AIX, Solaris, and so on. But the Linux distributors weren't able to bundle the JDK, because they didn't want it to bundle binaries. They wanted to build everything from source. So mostly, or all Linux distribution had Sun JDK bundled with it. They bundled GNU ClassPass and Apache Harmony and all this other stuff which was going on. And IBM heavily invested in Apache Harmony to come up with a VM, with a free VM.
It was the Apache Harmony, right? So
and
they always voted with no. This was
exactly. So all this development led Sun to finally open source OpenJDK, and Red Hat was one of the drivers in the background, because they wanted to bundle it with Red Hat Enterprise Linux. So I think they were really the first who built this and who came up with the first binaries to distribute it, because OpenJDK has always been a source only project. So people were, I mean, nowadays we have builds of the OpenJDK under GPL, but again only for only as reference implementation for the GA of a new release. But for example, for the update builds, there is no binaries available from OpenJDK. That's why projects like Adopt OpenJDK, for example, were created to basically build OpenJDK on different platforms, build it, test it, and because the OpenJDK project is not doing this. If you go on the release page in GitHub of OpenJDK, there is nothing there, right? Because there is no releases. And this was true from the beginning. And as you said, it was really very, very tricky to build OpenJDK in the beginning. Like the very first source drop was Hotspot only, even without class library. And then they also released the class library, but you still had these so-called binary encumbrances, which were some parts which they didn't open source initially. So you still
I remember that. There was a huge discussion with those. Right? There was some algorithm and compression or whatever. There was some small things which were still native, right?
Yeah, exactly. But then,
pardon?
Go on. Just
okay. Yeah. So what I already learned is this: how much actually SAP did for the ports. So you gained experience in all the platforms, and you became OpenJDK contributor. And the first ports were PowerPC and AS400 and S390.
S390, yes.
This is the IBM host machines where SAP run. And you got also the Java label on it, or was it OpenJDK still?
I mean, we still had we still run on with two implementations. We had our internal SAP JVM, which was built on top of the licensee sources. But once we contributed these ports to OpenJDK, we basically also got them back through our licensee channel. So it was
exactly. This was a good trick.
Yeah, it was a very tricky construct. But that was how we basically sold that to our management, why it makes sense to participate in the OpenJDK. Because before we participated, we had all these ports and we had to do a lot of changes to Hotspot to...
You had to maintain a Hotspot fork, which was expensive.
Exactly.
Yeah.
And that's why we say, well, when we contribute some of our ports to OpenJDK, together with these ports, we also contribute all the changes which are required to support this port. And that lands in OpenJDK. And OpenJDK was the source also for Oracle's JDK and for the sources we get from Oracle. So this made it basically trivial then to maintain our ports after JDK 8. Before it was like this, we did a port of JDK 6 for, let's say, Itanium, PowerPC, S390. And then for Java 7, like after 2 years, we just got a source drop of Java 7, which was all the difference between 6 and 7, but only for the platforms Sun had, like Solaris, Linux, and Windows, right? And then we had to basically merge this into our fork of
this is this is a hell on earth. This is incredible. As a low-level code, because you have your own forks, you have to maintain, what you did. And it is not even said that it was compatible, if you just merge without your modifications to 6 with 7, that it will work, So this is...
Yes. It like the jump from 5 to 6 took us like a few months. Then from 6 to 7, I think took us almost more than half a year until we
was that
the whole team working just on this.
I would suspect 5 to 6 was harder than 6 to 7. That's interesting.
No, because it was easier because we didn't have so many changes, right? But then 6 to 7, we had more ports and more changes. And then 7 to 8 became really, really painful. And
so you push to OpenJDK, you got your own changes back through the official channel. Exactly. What happens then? I'm really interesting situation now.
Well, that made it much easier because like from then on, like the upgrade to new Java versions for our internal SAP JVM became much easier because like the ports or most of the ports were already in there.
Yeah.
So it just worked more smoothly. And actually, we also got now the sources through the Mercurial repository, so we got like weekly updates, not just big major versions as source drops. So yeah, it became. I think it worked out very well.
Mm-hmm.
Then eventually we decided to do SAP Machine, which was an open source version of the SAP VM based solely on OpenJDK.
SAP Machine is open source based, and the certified one is what's
SAP JVM? Yes,
SAP JVM. Mm-hmm.
Yes, exactly.
On the SAP Machine can it call Java? So is it Java certified?
No, it's OpenJDK. I mean,
we cannot certify OpenJDK.
No, you can certify it, and you can call it Java SE compatible, but you cannot call it Java because you don't own the Java trademark. You have to own the Java trademark if you want to call it Java. You can say it's OpenJDK based, Java SE 17 compatible.
Yeah, this is what you can do. But without the certification, you cannot call it Java SE, right? You can say this is OpenJDK. If you
even with certification, you cannot call it Java SE. You can only call it Java SE compatible.
Compatible, okay.
Very tricky.
Okay, so but you can call it, at least Java can appear in the title. This is after the certification. And the trademark belongs to Oracle, so only Oracle can call something Java. So
yes, exactly.
Mm-hmm. Yeah. Or JavaScript even, right? Okay, but Java. Okay, no, this Java SE compatible, but I thought if you certified, you can call it Java, but the compatible I overlooked. So Java SE compatible. This was the thing. So SAP Machine is Java SE compatible?
Yes,
it's certified.
Most of the OpenJDK distributions from other vendors, like from Red Hat or Adopt OpenJDK.
And the SAP JVM is still around, or
it's still around, but I think it's only supported for up to Java 8. Like,
but it's not like no future. It's just legacy projects are using the SAP JVM.
We actually had another nice feature in SAP JVM. We did this Hotspot Express. Maybe you remember that was also done in the old days of Java when it took so long time for Java 9 to come out. So Oracle or Sun started in Oracle, then they just integrated new versions of Hotspot into JDK 8. And they called that model Hotspot Express. So as I said, Hotspot was in its own repository anyway. So from time to time, they just used a new version of Hotspot in JDK 8, which brought new features like better GC, faster JIT, and so on. But we did it to an extreme. Like we had SAP JVM, for example, we worked with Hotspot. SAP JVM 8 worked with the Hotspot from JDK 9 and even 11. So we had all the VM features from 11 and the performance, obviously, in SAP JVM 8, but also in 7 and 6. So like we had the fastest JVM 6 on the planet, I think, because SAP JVM 6 used the Hotspot or the VM from 8 or even 9 and 10.
So the engine was replaceable.
It was a lot of work to do that, but it was replaceable. And it's actually, IBM did the same with J9. Like J9 is much more modular than Hotspot. So in J9, the GC, the JIT compiler, the VM, they are all shared libraries, which can be updated more or less independently. So they could for a long time already. They had this design that on IBM J9 8 they could simply replace the GC with a newer one or the JIT compiler with a newer one, which was nice. And there was a long debate in OpenJDK around Hotspot Express model, but Oracle didn't want it to support it officially. Fun fact is that there is a Oracle JDK Performance Edition, I think it's called, for JDK 8, which runs on Hotspot from 17. So
Okay.
like for their commercial, it's only available for Oracle commercial customers. So for their commercial customers, they still did it, but in the OpenJDK, they rejected this idea. So yeah, that's
Yeah.
some code.
Management
Yeah.
decisions. But okay, so SAP Machine is now the official way to run even SAP SAP workloads, I
Yes.
guess, right? So right
Yeah.
now, and so what happened then? So you contributed more and more to OpenJDK, and then
Yes. Then I thought my task at SAP is done, and I decided to start a new endeavor at Amazon. So I joined the Amazon Corretto team, which is basically the
but
same
you
setup like at SAP, like creating a
and was it more or less serious what you said? I mean, it was like you say, okay, now SAP uses the open source version and it is successful. Now I need a new challenge. Was it like something like this?
yeah, basically. I mean, I was at SAP for 15 years when
Yeah.
I left, and I thought it's a good time to start something new. And there was this chance because Amazon was building up a new OpenJDK team. I knew some of the people working there from Sun Times, back from the old Sun Times, like Paul Honzi and Bernd Matiske, who were like the one who were the initial team members there, and Yishai Galatza, who was the manager. So yeah, it was a great challenge. And the other nice thing about Corretto and the Amazon Java team is that Amazon is actually a Java shop more or less compared to SAP. Where I told you that SAP still is it's mostly based on ABAP, and there are not so many.
This is not true
Java
because
modules.
I I had a workshop with I don't know how many hundreds ABAP developers, and officially they should do Java all the time after my workshops, and enjoy it really in leisure and at work. So after my I don't know where it was, maybe 2006 around, I guess something like this, 2006 2007. So there was like initiative that everything has to be Java, and I had the chance to teach hundreds of ABAP developers, and this was quite an interesting experience because we had to know it is complete opposite worlds, Java and ABAP. For instance, for us, reuse back then was big, and I remember I had a chat with SAP. I was like, yeah, it's not about reuse. We could reuse whatever you like, but if I reuse something, I have to commit to the interface. I have to maintain it. There's complete different thinking, and also so it's really very interesting experience for me, and I hope for the other developers as well. Yeah, but I was just kidding. So, but it was a nice experience in St. Leon Road, but I think,
Yeah,
and I was Waldorf, and also what I did, I was invited to SAP, and for you remember Web Dyn Pro, I think.
yeah, WebDyn Pro,
So
yes.
I was in the first because I was in the first iteration, help a little bit with the architecture. It was like the action-based frameworks similar to Struts, and then I was no more available. It's like yeah, but this also. So I was in Waldorf a few times and in St. Leon Road. So there was some Java. Okay, Volker, the problem is Coretta is even more interesting, so I have to reinvite you back.
Let's see. I don't want to spam this channel.
No, this is the really interesting discussions, and I'm still thinking. I have to admit, maybe next time I will ask you about the deoptimization again, because what I still don't understand is why you cannot just reject and do it again. Why you have to know where you were before. If you could remember where you were, and then optimized and reject the optimization and just do it again. But it seems like it's not that easy. So I will try to read and ask you again a more intelligent question next time.
No problem.
Very good. Then where people can find you? This is the old question on this channel.
Yeah, people can find me on Twitter or email. Like, I think I have a quite unique name. Like, if they Google Volker Simonis, they will find
Volker
me.
Simonis.
Yeah.
And in OpenJDK commits still?
Yeah, I'm still doing some work on OpenJDK, not so much. Like recently, I think the last year or so, I started looking into GraalVM a little bit. GraalVM, Polyglot, GraalJS, Graal Native Image. because it starts to get an interesting topic also at Amazon. There is demand for it, so we are thinking how we can support it.
Perfect. Then thank you a lot and see you next time.
Yeah, was fun. Bye.